Lesson 6.6 is all about analyzing graphs of quadratic functions. And more specifically, before we've been looking at standard form, we're now introducing the vertex form of an equation. Remember, standard form was when we had ax squared plus bx plus c, where a, b, and c are all real numbers and a can't be 0. That was one way of looking at a quadratic function. Now in vertex form, we would say that our f of x equals a times the quantity x minus h squared plus k, where a, h, and k are all real numbers, and again, a cannot equal 0. And when we have functions given to us in this vertex form, again, just like standard form, there are some tricks. Our vertex is always going to be the point hk. So as long as it's given to us as minus h plus k, the vertex would be hk. Our axis of symmetry, I want you to fix this here. I don't know why it came out as a. It's supposed to be x equals h. So just like before, where the axis of symmetry we would say is x equals the x coordinate of the vertex, still here the x coordinate of the vertex is h. So we would just say the axis of symmetry is x equals h. And also similarly to the standard form, anytime a is positive, then it opens up. Anytime a is negative, that implies that the parabola is opening down. So these are, this is vertex form. So we're going to look at how standard form and vertex form both work. We're going to look at our parent function of just a simple parabola of f of x equals x squared. So if we wanted to look at it as vertex form, we would say that it was f of x equals, remember it's a x minus h squared plus k. So our a is 1, x minus 0 squared plus 0. So if we were to simplify this function down, x minus 0 is just x, x squared. Then x squared times 1 is, we just have f of x equals 1x squared, or just x squared, plus 0. And we don't need that plus 0. So that gives us our f of x equals x squared. So that's how it looks in vertex form. If we wanted to see it in standard form, so again, we'd have f of x equals ax squared plus bx plus c. Or we'd have ax squared plus 0x plus 0. And again, because our b and our c are just 0, we're only left with this x squared. So that's how it looks. So in these cases, again, looking at it from vertex form, our vertex is h and k. Again, remember this is minus h, so our h that we're looking at is just the 0, so it's 0, 0. If we wanted to find that in standard form, we'd have to do negative b over 2a, which would be negative 0 over 2 times 1, which would give us 0. That would just be the x coordinate, so that would be this part. And then we'd have to solve for the y. So in vertex form, it's a lot easier to find where the vertex is at. And since we know where the vertex is at on our table, we'll just put that right in the middle. Now, if we want to find some points that are around that, we'll just go minus 1 and minus 2, positive 1, positive 2. So we're just doing nice points that are close to or around this 0. So if we plug them in, so we'd say negative 2 squared, that gives us 4. Negative 1 squared gives us 1. 1 squared gives us 1. And 2 squared gives us 4. So we have 4, 1, 1, and 4. So in this case, the parent function, remember, simple parabola, has vertex at 0, 0. And we have a point negative 2 up 1, 2, 3, 4, 1, 1, or negative 1, 1, positive 1, 1, positive 2, positive 4. So this is what our parabola is going to look like. If we want to look at it in vertex form and analyze it. Other things that we want to look at are the axis of symmetry, which remember is an equation. X equals the x coordinate of our vertex. So it's going to be x equals 0. And we also want our y-intercept, which is where it crosses the y-axis. In this case, it's best to find the y-intercept if we're looking at standard form, because it's just our last value there. So we'd say it's 0. Or again, we can look at the graph here, and we would see that it hits the y-axis right there at 0. And that its x-axis is x equals 0. Goes right through that line there. So that's what the parent function looks like, looking at it swapping between standard form and vertex form. Now let's say we wanted to graph and analyze a function given specifically just in our vertex form. So this time it is y equals the quantity x minus 3 squared plus 2. So one of the first things we want to look for is what is the vertex. So again, when it's given to us in vertex form, we have minus h and plus k, and our vertex is hk, so 3 is the x-coordinate and 2 is our y-coordinate. So that's where our vertex is going to be. So we can plot that on the point right away. 1, 2, 3, 1, 2. There's our vertex. We can also put that on our chart right away. We'd say 3, 2. Other things we want to look at is equation of the axis of symmetry would be x equals 3, which I found right there. So we would draw that line, x equals 3, goes right down the side there. And we'd also want to know the y-intercept, which, looking just at the vertex form, we would have to plug 0 in for x. So we would say 0 minus 3 squared plus 2. 0 minus 3 is negative 3 squared plus 2. Negative 3 squared is 9 plus 2. 9 plus 2 is 11. So our y-intercept is 11. Since we know that our y-intercept is 11, that's going to be where x is 0. So if we plot our point 0, 1, 2, 3, 4, 5, and 6, we know that 0 is going to be right at 11, because that is our y-intercept. Now we need to solve for a couple other points here. So again, we just plug some numbers in here, like our 1 minus 3 squared plus 2. 1 minus 3 is negative 2 squared plus 2. Negative 2 squared is 4. So I'm just going to go 4 plus 2, which equals 6. So when we have 1, we get 6. And I'm going to give us some more room to work. Let's do 2. So 2 minus 3 squared plus 2. And again, we're getting this directly from our formula, our function at top. 2 minus 3 is negative 1 squared plus 2. Negative 1 squared is 1, then plus 2, which gives us 3. Again, because we have an axis of symmetry through our parabola, then we'd say as long as we are starting from our vertex over here, and we only go 1 away here, and we go 1 away this way, they should come out to the same answer. So this one should also be 3. And to check, we could plug that into our function, which if you'd like to do that, I'll let you do that on your own time, but for sake of time, we're just going to go ahead and notice that from 3 to 5 is the same as going from 3 to 1, and from 3 to 6, same as going from 3 to 0. So these will all come out to be the exact same. So we'll start at our with our chart here and plotting out some points. 0 is going to be 11, so that's going to come way up here. Where we have 1, we have 1, 2, 3, 4, 5, 6. At x is 2, we have 3. We already have our plot 3, 2. Now we have 4, 3, and 5, 6, and 6 comes out to 11 way up there again. So it looks like our parabola is going to look something like this. And again, we've already analyzed it. You see that our y-intercept is 11 and our axis of symmetry is x equals 3. So that is how we would graph and analyze this function in vertex form.